Good morning, students. Today we are learning the 10th class chapter 1 real numbers. For this one, yesterday we learned about the real numbers, what are composite numbers, what are integers, what are natural numbers, what are rational numbers. If you are having any doubts, you can check our other video which we posted yesterday. Okay, students, 900 and 270. For doing this sum, here always the bigger number is A, smaller number is B. Okay, now by using Euclid's algorithm Lemma, by using Euclid's algorithm Lemma, the formula for this one is equal to A is equal to BQ plus R. Okay, A equal to BQ plus R. Here what we have to do first, 270 divides 900. So 3 is 0. 90. So here according to this formula we will write as 900 equal to B is 270 into 3 plus 90. Here in this sum we didn't got the remainder as 0. So we have to do further it. That is again here bigger number A is equal to 270, B is equal to 90. Now applying the same formula, that is 270 equal to B is 90. Again we have to divide this one, that is 90 divide 270 3 times. So 90 into 3, here we got the remainder 0. Then here we got the remainder as 0. So therefore 90 is the HCF of 900 and 270. Understood, students? Now, next question. That is 196 and 38220. We have to use the same Euclid's formula method. That is A equal to BQ plus R. Here A is a bigger number again, 38220. B is equal to 196. So according to the formula, we have to go for the division. When we are dividing, we are getting 195. That is 38220 equal to 196 into 195. Remainder we are getting as a 0. So by using the same method, we are getting the answer as a 0. So final answer, therefore 195 is the HCF of 196 and 38220. Okay, students. Now, students, this is the third bit of the same exercises. That is 1651 and 2032. So your bigger number is 2032 and small number B is 1651. Again applying the same formula, that is A is equal to BQ plus R. Here, see this one, first we are dealing with this number. So when we are dividing it now, 2032 equal to 302 equal to 1651 into 110. This is 4 times 1 time equal to this is plus 381 we are getting. Now again we didn't get the remainder 0. Remainder is not 0. So what we have to do? That is again A is equal to 1651, B is equal to 381. That is applying the formula, that is 1651 equal to 381, this one is here, into 4 plus 127. Here also we didn't get the remainder 0. So again we have to go for the further division. That is A is equal to 381, B is equal to 127. Now applying the formula here, that is 381 equal to 127 into 3 plus 0. This one we solved here. Okay, now we got the remainder equal to 0. So therefore HCF of 1651 and 2032 is 127. Okay students, here according to the sum, 0 is less than B is 5. So we are taking as R as a remainder. What we have to take? Where this is R, not X, where R is equal to, we are starting from 0. 0, 1, 2, 3, 4, 5. Because it should be less than 6. That's why we are taking this like this. Now, according to the question, that is A equal to, B is what we are taking as a 6. Q is the same. Now R is what we are taking as a 0. That is now A is equal to BQ. This is 1. Now R we are taking as 1. Substitute here also. A is equal to 6Q plus 1. That is 6Q plus 1. This is second. Now again R remainder is 2. That is A is equal to 6Q plus 2. This is third. Now substitute R is equal to 3. That is A equal to 6Q plus 3. Now R equal to 4. That is A is equal to 6Q plus 4. Now R equal to 5. That is A equal to 6Q plus 5. So up to, it should be less than 6. So we are going up to 5 only. Okay. Now in this sum, he is asking first odd. Odd means this one, this one, this one. So others are even numbers. So we should not take that even numbers. Therefore odd integers are only 6Q 1, 6Q plus 3, 6Q plus 5. Okay students, understood? Now next question. That is third question. Show the square of positive integers is in the form of 3p or 3p plus 1. Here in this sum, what we will do, we will take a is in the now next question. Show the square of positive integers is in the form of 3p and 3p plus 1. Here in this sum, now we will do as let a be the square of an integer by using let a be the square of an integer. Okay, we are using the same formula, that is a is equal to bq plus r. Understood? Now here 0 remainder. Why? Because in the question they are giving 3. That's why we have to get the remainders are 0, 1, 2. So we have to apply the 3 for the sum. Before the sum, how we are doing? The same way we have to do here. But in this sum, we have to, question is asking for the square. We have to do the squaring. Okay. Now, a is equal to 3q plus 1, 3q plus 2. These are all the things we have to go. Now, what we have to do in this sum? We are going for the square, that is a is equal to 3q, here squaring both the sides. So that is a square equal to 3q whole square. That is answer equal to 9q square. Now here we will write as 3 into 3q square. We will convert this 3q square as a p. Okay. Now next, this one, a is equal to 3q plus 1. Again squaring both sides we have to do. That is a square equal to 3q plus 1 whole square. Now this one is a square equal to, we have to expand it, 9q square plus b square is 1. This is 9 to 6q. Here we have to, I am taking as a 3 common, 3q square plus 2q plus 1. Here this value I will take as a p. That is a square equal to 3p plus 1. Now again one more thing is left out, that is 3q plus 2. A is equal to 3q plus 2. Here also squaring both sides. That is a square equal to 3q whole square. This is 12q. 4 I can write as 3 plus 1. Now I will take the 3 common in these 3 things. 3q square plus 4q plus 1 plus 1. This entire thing I will write as a p. That is 3p plus 1. Okay students? Now students, the next question. Fourth question. Show the cube of the positive integer is in the form of 9m plus 1, 9m plus 8. This is also the same sum. Let a be the cube of an integer. Same formula. It should be less than 3. So our values we have to take as 3. Before the sums also we have to do directly, but we have to write as a case 1, case 2, case 3. In this sum we will deal with the case 1. First case. We are taking the r as remainder as 0. Now substituting in our formula. A is equal to, here a is equal to same a only, b is equal to 9, r is equal to 0. Now substitute in the formula as A is equal to BQ plus R. That is A is equal to 9. Q is Q only. R is 0. Now in this sum is asking for the cube. So we have to cubing both sides. That is A whole cube equal to 9Q whole cube. Now when we are cubing it now, A cube is equal to, so we have to get in the form of AM. 9 9s are 81, 729 cube here. Now what I am doing here, I am taking 9 common in it, so I will get 81 cube. Here this value I will convert as EM. So first one we got. Now case 2. Here R is equal to 1, A is equal to A only, B is equal to 9. Now we are substituting it in the formula A equal to BQ plus R. That is A is equal to 9Q plus 1. Here we have to do cubing both sides. That is A cube equal to 9Q plus 1 whole cube. That is equal to 81 Q square. Now see, A cube is equal to 729. According to the formula, A plus B whole cube is equal to A cube plus 3A square B plus 3AB square plus B cube. So we are substituting that formula. We got the answer like this, and we will take this all things as a EM. Now what do we got? A cube equal to 9M plus 1. Okay, then we have to go again. Case 3. Case 3, R equal to 2 we have to take. A is equal to A, B is equal to 9. Same formula, that is A is equal to BQ plus R. That is A is equal to 9Q plus 2. Again here cubing both sides. That is A cube equal to 9Q plus 2 or 9 A cube plus 3 A square to B plus 3 B square plus B cube. Now we get as a 729 Q cube plus 81 into 648 486 Q square plus 12 nines are 72 Q plus 8. Now here also 9 we have to take common. When we are taking 9 common, 71 Q cube plus 9 if we are taking common here, 54 Q square plus 72 9 8 sum. Now we will write this entire thing as a m. Hence, what is asking, we proved it. Now, fifth question. Show one and only one out of n plus 2, n plus 4 is divisible by 3. Let n be any positive integers from lamina a is equal to bq plus r. Condition is same like the previous one only. In this condition, we will take a same formula we are applying, that is case 1. A equal to 3q, r equal to 0, I am taking 0, 3q we got, it is divisible by 3. Now next condition, n plus 2, that is 3q plus 2 plus 0, this 3q plus 2 we got. It is not divisible by 3. Now another condition is there, that is n plus 4, that is equal to 3q plus 4 plus 0, we will got as a 3q plus 4. It is also not divisible by 3. This is under the case 1 condition. Now, case 2 condition, that is n first. That is same formula, a is equal to 3q plus 1. In this condition, it is getting 3q plus 1. It is not divisible. Divisible by 3. Now, n is equal to 1 only, but n plus 2 condition will apply. 3 came. It is divisible. Divisible by 3. Now next condition, n plus 4 equal to 3q plus 4 plus 1. That is 3q plus 5. It is not divisible. Okay. Now another case is there. Now case 3, that is n is equal to 0, that is 3q plus 2 plus 0. Formula we know na, a is equal to bq plus r. R value we are taking as 2. So we are getting as 2q plus 0. It is not divisible. By 3. Now, n plus 2 equal to 3q plus 2 plus 2. That is equal to 3q plus 4. It is also not divisible by 3. No, n plus 4 condition we are taking. That is equal to 3q plus 6. 3 will divide by in both of the things, so it is divisible by 3. Understood, students?